Okay, so in this problem, it's a static friction problem. We're being asked, does the crate move down the incline? So asking the question, does the crate move, that is the same as asking, is the force of static friction greater than the maximum possible force of static friction, assuming the acceleration is equal to 0. Right, these two questions have the identical answers. So what we're going to do is we're going to assume the acceleration is equal to 0, and we're going to solve for the force of static friction, and we're going to compare it to the maximum possible force of static friction. And if it's greater, so if the maximum possible force of static friction is 50 newtons, but we need 150 newtons to keep it in place with static friction, then that's not going to work, and it's going to move. All right, so let's see. To work this out, I'm going to need to draw a free body diagram. So we'll start off here. We've got gravity, which of course has parallel and perpendicular components. The parallel component of gravity is mg sine 35. Perpendicular is mg cosine 35. There's a normal force. We've got our applied force over here of 450 newtons, which is going to be a little tricky, right? It's got a component that's parallel to the ramp and a component that's perpendicular to the ramp. And the parallel component there is 450 cosine 35, and the perpendicular component is 450 sine 35, if you can read that. Okay, and then we've got a force of static friction. So I have to decide whether or not the force of static friction points up the ramp or down the ramp. I also need to establish a sign convention. I'll use this sign convention that the ramp is positive. Well, rather than guess, let me work out the parallel forces. Okay, the force of static friction has to equal the sum of the other parallel forces and point in the direction opposite. So if I look at the parallel component of the applied force, that is 450 cosine 35, right? And that is 368.6 newtons. Now let me look at and that points up the ramp. Now let me look at the parallel component of gravity. That is mg sine 35. Oh, yeah, mg sine 35. And since m is 140 kilograms, I take 140 times 9.8 sine 35, and that is 787, or I guess 786.9 newtons, and that's down the ramp. So if I sum up the other parallel forces, they add up to a net force that points down the ramp. Therefore, the force of static friction must point up the ramp. Okay? So let's see. Let's go ahead and write that out. So the sum of all parallel forces is the force of static friction, which is positive because it points up the ramp, minus the parallel component of gravity, that points down the ramp, so it's negative, plus the parallel component of the applied force, which is 450 cosine 35, that's up here, that points up the ramp, so it's positive. That's got to sum to 0 because we're assuming, of course, that the acceleration is equal to 0 up here. So if I solve for the force of static friction, I get that it is 420 newtons in a direction up the ramp. Now I've got to compare that to the maximum possible force of static friction. Right? So the maximum possible force of static friction is mu sub s times the normal force. I need the normal force. Now the normal force is going to be kind of a pain to calculate because I got all these other perpendicular components. So let's work through it. Sum of all perpendicular components. The normal force is positive, points up out of the ramp. The perpendicular component of the applied force is negative. It's 450 sine 35 because that points into the ramp. the perpendicular component of gravity is also negative. Right? It's mg cosine 35. That's got to sum to 0. So if I add all that up, the normal force is equal to 1,382 newtons. And so the maximum possible force of static friction is mu sub s 0.44 times 1382, which is 608 newtons. Okay, so the force of static friction is less than the maximum possible force of static friction. Therefore, the crate does not move. And since our answer is no, that it does not move, then we need to know the magnitude and direction of the force of static friction. Well, we've already got that. We'll solve for that up here. So that is our answer. Now, if the force of static friction had been greater, let's say the force of static friction needed to keep this in place were like 800 newtons, then that would mean that the block moves, and I would have to redo the problem using that coefficient of kinetic friction of 0.25. But since that's not the case, I'm done.